We were 3 hours into a tenant outage when someone said, "The breaker diagram's in the closeout folder," and that folder's on a consultant's laptop in another time zone. By the time anyone found the right step, the whole floor had complaints.
Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today, maintenance as code, the one-page runbooks and tiny automations that stop those 3-hour headaches from happening. With me are Michael Harrington and James Rogers to walk through what works in the field and what quietly makes operations resilient.
Glad to be here. From an operational standpoint, small documentation decisions are the difference between a 30-minute fix and a day-long outage.
Wow.
And the tech rarely fails in isolation. It's the loss of tacit memory. Someone knew which sequence to run. They left, and suddenly the memory is gone. Reliability starts with disciplined maintenance, and runbooks are the shared memory.
Okay, quick picture for listeners. Hot Monday, building loses AC, vendors and staff bouncing messages. A 30-minute reset turns into 4 hours of tenant calls. What exactly goes wrong in that stretch? Michael, what breaks if this goes down?
Right. It's more than comfort. Tenants feel it immediately. Tickets, lost productivity, sometimes penalties. In that scenario, the team had a 40-page closeout TDF with the fix buried inside. Nobody wanted to dig through that in a crisis.
So the artifact existed, but access and format failed the people doing the work.
Exactly. That's why we aim for a one-page operational play. Trigger, prerequisites, clear steps, and measurable acceptance. If a technician can follow it at 2 a.m., it works.
Walk me through an example one-pager. Keep it tight. What's on it?
4 blocks. Trigger, prerequisites, steps, acceptance. Example trigger. Networked chiller reports fault X for 2 consecutive 5-minute polls. Prereqs. Building in occupied mode. Vendor contact verified. Steps. 1. Check breaker A. 2. Cycle control power. 3. If fault persists, switch to manual cooling and notify vendor. Acceptance. Chiller returns to auto, supply temperature stabilizes within 15 minutes. 1 line for rollback and contact info. 1 page.
I'm not sure I buy that. Don't teams just turn this into a checkbox exercise and log whatever they did?
Fair. Checkboxing happens if governance and feedback aren't built in. Start with short validation cadences and require 1 observation note. If a smoke test says pass, but notes valve slow to respond, that note becomes the improvement ticket. Also assign a named owner, say the role, not the department, who runs the test and owns follow-ups.
Rotate who runs it too. If the same person always does the test, knowledge doesn't spread. Have the lead tech, an apprentice, and an on-call run it in rotation. It creates redundancy and human memory.
What about cadence? How often should teams run these smoke tests? Quarterly? Monthly?
Quarterly is a solid default for most systems. Critical systems might be monthly. The key is short, 10 minutes max. If a test takes longer, it won't happen. The owner runs the test, logs the result, and if it fails, triggers corrective action.
Let's talk automation trade-offs. There's a temptation to automate everything. Michael, you warn about brittle automations. Tell us why.
Automation is fantastic for deterministic checks, heartbeats, point reads, alarm counts. But automating corrective actions without human context that's fine until it fails territory. An automated reset executed at the wrong time can cascade. Start with detection automation, attach the runbook, and keep human verification before corrective steps.
Preventative maintenance is where automation shines if done right. Automate daily health reads and flag drift. Let people do the fixes that require judgment. The goal is to free staff for preventative work, not replace their judgment.
Give me a starter automation teams can build in a week that actually returns value.
Daily health check. Read 5 critical points. Power status, supply temp, pump run status, controller heartbeat, alarm count. If any point is out of range, generate a ticket and attach the relevant 1-page runbook. Deterministic detection, human decision for fixes. Low risk and big payoff.
and build clear acceptance criteria into both the runbook and the automation. Don't say, system seems okay. Say, supply air within 2 degrees of set point and no active faults for 10 minutes. Measurable criteria avoid arguments in a crisis.
All right, we're almost at the finish. Michael, James, give listeners 3 concrete next steps they can take this week to get maintenance as code moving.
I'll add run the pilot test, capture 1 observation sentence, and iterate. Start a simple daily health check automation that opens a ticket and links to Runbook. Measure time saved on the next incident. Real metrics build buy-in.
Some teams will still say we don't have time. Michael, short answer to that pushback?
Pilot one system. If that one runbook shaves an hour off the next incident, you've bought time and evidence. Use that metric. It's persuasive to leadership. Small pilots beat big promises.
And don't forget the goal. The best day in operations is the one nobody notices. Make failures routine, short, and documented. That's quiet reliability.
For listeners who want a starter kit, download the one-page runbook template at gds.tech/runbook. Try a pilot next week. Pick a system, assign a named owner, run a 10-minute smoke test, and tell us what you learn. We'll share lessons on a future episode.
Quick tip. Write the runbook so a new tech can follow it at 2 a.m. If they can, you've won.
And remember, assign ownership, keep tests short, and store the runbook where operators actually look. Small discipline, big dividends.
That wraps up this episode of Built, Wired, and Secured. Thanks for spending a few minutes with us. Built to last, wired with intention, secured for the real world.